1998, number 84. So what do they want? They want to know what K is. Now this one, there's a fast way and there's a not so fast way. I'm going to do the long way first and show you what you're supposed to recognize to make it a shortcut. So they're giving us the population doubles every 10 years. So if we had the equation of the population, that would help us. This is the growth rate, all right? But it's not telling us the population. So the long way to do this is solving for y. We're going to use separation of variables. So anything with a y, we're going to put on one side, and anything else we put on the other. Okay, I just messed up there. K dt. Now we're going to integrate both sides. This side will be ln absolute y. This side, it's a constant, so it'll be constant times time plus c. Now to get rid of ln, we e both sides. Those will cancel. We get absolute y equals e to the kt plus c, which changes to e to the kt times e to the c. And the reason your properties of exponents, when you multiply two exponents with the same base, you add these, which happens here. Okay, now here is where it gets kind of tricky. When I get rid of the absolute value sign, I get a plus or minus. And I'm going to put e to the c first and e to the kt last. I just switched the order of these. And the plus or minus because I got rid of the absolute value signs. Now, I'm going to I can't use k. I'm going to do z equal plus or minus e to the c. And what that does for us, I get z e to the kt. Now, this is exponential growth formula. You might recognize it from biology or chemistry, and it's usually the form like this. Whoopsies. Exponential growth. This is your starting amount. This is your ending amount after time t, and k is some constant. Okay, so here's the deal. If you recognize this, where the growth rate is dependent on is proportional to the population. So you notice our population is y. If we have y times some constant k, you can automatically go to this formula. Starting amount, ending amount. Okay? And how do you know that's the starting amount? Well, if you were to put time t equals 0, e to the 0 is 1. So at time 0, the amount you have is here. That is your starting amount. So that is what's going on here. We're told that the population doubles every 10 years. So that means if you start with y0, after 10 years, you're going to end up with twice what you started with. This is the ending amount. That's your starting amount. Okay? And so now you can solve by dividing both sides by y0. You ln both sides. Why would you ln? Because the ln and the e cancel. So you get ln of 2 equals 10k. Divide both sides by 10. And you do that in your calculator. ln 2 divided by 10. Let me find my calculator and do that real quickly. So I'm going to clear my screen. ln 10 divided by 2. I get 1.151, which would lead me to not the right answer. Let me see if I did this right. The population doubles every 10 years. The population doubles every 10 years. ln 2. Let me double check. Oh, I didn't do it right. Try it again. ln of 2 divided by 10. 0.0693. I just punched my calculator wrong. 0.0693. There's your answer, A.